graph absolute value functions. How do we know that we're looking or dealing with an absolute value function? Like, what's the key? What are we looking for to know that it's absolute value? The absolute value bars. If you look at the first example down here, we have g of x equals the absolute value of 1/3 x minus 2. Those absolute value bars are our giveaway. That lets us know that we're dealing with absolute value. What does the graph of an absolute value function look like? A V. It makes the shape of a V. If our graph makes a line, we either have done something wrong or we haven't picked enough points. It should not make a line. It should be a V. It may start off looking like a line, but it won't finish that way. Okay, so for this particular problem, I've got 1/3 x minus 2. Let's draw an XY chart. You get to pick values for x. I'm going to pick 0, 3, and -3 this time. Why did I not pick 1 or -1? I don't know. Well, what's going to happen if you take 1/3 times 1? It's going to be a fraction. 1/3 times 1 is 1/3. And then I have to do 1/3 minus 2. I'm going to have a decimal. Sometimes you're going to have decimals. They're unavoidable. But I'm thinking ahead. I'm thinking, let's avoid those decimals and fractions. Let's pick something that I can easily multiply by 1/3, like 3 and -3. Remember, in your T-chart, you can pick whatever numbers you want. So let's start with 0. If we put 0 in for x, 1/3 times 0 is 0. And 0 minus 2 is -2. The absolute value of -2 is 2. So my first point is 0, 2. Go ahead and plot that on your graph. The next number that I'll put into my function is 3. 1/3 times 3, what's 1/3 of 3? 1. And 1 minus 2 is -1. The absolute value of -1 is 1. Let's put -3 in. 1/3 times -3. 1/3 of -3 is -1. And -1 minus 2 is -3. The absolute value of -3 is 3. Right now it looks like our graph is going to be a line, doesn't it? We know better than that. We know it's not really going to be a line. It should be a V. So let's pick some more points. Should we pick more positive numbers or more negative numbers? Positive. That way we know where we want to figure out where V's going to go down and come back up. So I'm going to jump and I'm going to put 6 in. You could put 4, you could put 5, but I'm thinking ahead. I'm thinking let's multiply. Let's substitute something in that's going to be easy to multiply by 1/3. So what is 1/3 times 6? 2. And 2 minus 2 is 0. And the absolute value of 0 is 0. Let's put another positive number like 9 into our function. 1/3 times 9 is 3. And 3 minus 1, 3 minus 2, excuse me, is 1. The absolute value of 1 is 1. At this point, it looks like my graph is starting to go back up, doesn't it? Let's put another number, one more positive, maybe 12. Even though 12 is off of our graph, I can estimate about where 12 would be. So let's put 12 in. 1/3 times 12 is 4. And 4 minus 2, the absolute value of 2 is 2. At this point, I think we've got a pretty good graph. We can see that, starting to go back up on the right-hand side. Take your straight edge, please, and draw your sides of your absolute value function. I do want you to make sure you include arrows on the ends of your graph to show that they do keep going in both directions. Okay, the next thing I want to do is find the domain and the range. Remember, domain is your input. Those are the numbers you can put into your T-chart. Well, I picked 0, 3, -3, 6, 9, 12. Those are my domain values, but I could have picked a lot more numbers, couldn't I? In fact, I could have put anything I wanted in for x. When we can put anything we want in for x, what do we say our domain is? All real numbers.
Is that always going to be that?
For absolute value functions, yes. For the range, I'm going to use my sticky notes that we used yesterday. You got those, Matt, grab them. Okay, for this particular function, I'm going to put my sticky note at the bottom of my graph. I know its lowest point. All of the other values are above 0, agreed? 0 is my lowest point, right here. I'm looking at the y value of that point. It's 0. All these other y values are above. That's 1, that's 2, 3, 4, 5, etc. They're all greater than 0. So we'll say that our range, which is dealing with y, is greater than or equal to 0.
Is that answer always going to be that?
No. It just so happened that all of them last time were. It won't always be that way. It just depends on whatever the lowest or highest point on your function is. Alright, let's move over to the back side. Let's do some more. This time we're graphing h of x equals the absolute value of 1/4 x plus 1. State the domain and range. I'm going to start by doing an XYT chart. We're going to pick values for x. I'm definitely going to put 0 in. What would be another good number to put in? 4 and -4. And again, we pick those numbers because we want to be able to easily multiply by 1/4. And 4 and -4 are good at that. So let's put 0 in first. 1/4 times 0 is 0. And 0 plus 1. And the absolute value of 1 is 1. So 0, 1 is my first point. Let's put 4 in for x. 1/4 times 4 is 1/4 times 4? 1. And 1 plus 1 is 2. The absolute value of 2 is 2. I like to plot my points as I find them. Put -4 in. 1/4 times -4 is -1. -1 plus 1?
0.
And the absolute value of 0?
0.
0. Should we pick additional positive numbers or additional negative numbers? Negative. Right now my graph looks like a line, and it's not. I need to pick more values. So I might put in -8 and -12. So if I put -8 in, 1/4 times -8 is -2. And -2 plus 1, -1. The absolute value of -1 is 1. Put -12 in. 1/4 times -12 is -3. -3 plus 1 is -2. And the absolute value of -2 is 2. Remember, -12 isn't on our graph, like in the last example, but I'm going to just extend my x-axis here and plot that point. I think we've got a pretty good graph. Let's look at the next one. Oh, let's back up. Let me do domain and range. For our domain, again, we can pick anything we wanted for x. We just happen to pick multiples of 4. What's our domain? All the numbers. Put anything we wanted for x. For the range, take my sticky note and put it at the bottom of my graph and close off that graph there. I know that I'm not going to have any values lower than 0. 0 is my lowest point. All the other y values are greater than 0. So y is greater than or equal to 0. One more. This will be our last one. It says to graph g of x equals the absolute value of 2x plus 1. Now this one is a bit different. This time we've got to do that plus 1 after we take the absolute value. So keep that in mind. Do I need to worry about picking numbers that are easy to multiply by 2? No, I can put anything in. I could have put anything in the other ones as well. Just, we were trying to make it easier to multiply. I'm going to use 0, 1, and negative 1. Put 0 in for x. 2 times 0 is 0. And the absolute value of 0 is 0. Plus 1? 1. Put 1 in. 2 times 1 is 2. The absolute value of 2 is? Plus 1? 3. Put negative 1 in next. 2 times negative 1?
Negative 2.
Negative 2. The absolute value of negative 2?
2.
Plus 1? 3. We could go ahead and draw our v in, couldn't we? But I like to pick a couple more points just to be certain that we didn't make a mistake. Let's go ahead and put 2 and negative 2 in. If I put 2 in, 2 times 2 is 4. The absolute value of 4 plus 1? 5. Put negative 2 in. 2 times negative 2? The absolute value of negative 4? Plus 1? At this point, I think we've got a good graph. Go ahead and draw in our sides. Okay, what's our domain? What numbers can we put in for x? All real numbers. We can put anything we want. We could have put fractions and decimals, negatives, positives, anything that we wanted in for x. We weren't limited. How about our range? Anybody have a guess what it might be?
1 is greater than or equal to 1.
Thanks, Hannah. That's okay. You are correct, though. Y is greater than or equal to 1 is our range. Let's talk about y. Look at your graph. What is the lowest point this time? It's 1. It's not 0 anymore, is it? The lowest point is 1. All these other y values are above 1. They're greater than 1. So our range is y is greater than or equal to 1. What would happen if, this is not on your notes handout, but draw a picture here. What if this was our graph right here? What would your domain be? Hold on. Domain is your input. You could put anything in, right? I mean, there's always all real numbers. What about the range? What would your range be? Y is greater than or equal to 4. The lowest point in our graph is at 4. All the other points are greater than 4. Y is greater than or equal to 4. What if our graph was right here? was our graph. What's our domain here?
Or numbers.
Domain is our real numbers. The range,
Negatives. I is equal to -7.
what'd you say?
-7.
I think we're at 6, -6.
Okay.
That's tough to see. So yes, go ahead, Olivia, you said y is
Equal or greater to -7.
You
Or
got it.
6, and then
-6, yeah. Y is greater than or equal to -6. So it all just depends, your range is gonna depend on where it falls on the y-axis, what that lowest point is. What if, one more. How would it be, what would your range be? Obviously the domain would still be all real numbers.
-2.
Okay, so what would we say about -2?
Y is greater than or equal to -2.
Is that true? Is -3, -4, -5, -6 greater than -2? It would be less than. Y is less than or equal to -2. All these other points are less than -2. Alright, we're going to do some more practice here with graphing absolute value functions. The assignment's going to be out of your book again, and I've got graph paper for you to use. On page 265, 21 through 24. What's that? 21 through 24. If you guys want to group up and work, and it's a group of 2 or 3, I'll let you do that as long as you're on task.